Okay, ladies and gentlemen, for IED, what we're going to be doing today is we're going to be doing making holes in CAD. This is activity 1.3.2, and this is going to be the second part to our making holes. So the first time, what we did and what we turned in was we turned in some hole notes for part A, part B, and part C right here. What we're going to do now is we're going to be creating 3D models of parts of our Trammel toy. And the way that a Trammel toy works, let me go ahead and show you really quickly what a Trammel toy is before I continue talking about it. And people are like, I don't even know what's going on. Like, Trammel toy? What is this? This is some weird stuff that Mr. Broadway's talking about, and I don't really know what's going on. So I'll go ahead and I'll show you what the whole shape of a Trammel toy looks like. If I can actually find it in my, there it is. So I'm going to go ahead and open this up and let it load so you can see what a Trammel toy looks like. Some of you guys haven't actually seen one before, but it's going to be a whole bunch of different parts that are going to be put together, and we're going to go through the process of creating these parts, either through 3D printing or laser cutting, or none of these parts will actually be available to us. We're going to have to create everything from it. And this is what a Trammel toy looks like. You're going to have two basic slides here, and the slide from one side is going to move while the slide from the other side moves. You kind of twist this around and crank it around a little bit, and they don't collide with each other. So because these are separated away from each other, it is physically impossible for them to be able to hit each other because of the nature of the machine. So what we're going to be doing is we're going to be working on this base plate down on the bottom, down here. We're going to be working on the base plate. These top parts were 3D printed, and we've already made some measurements with those. We're going to be working on the base plate down on the bottom. So here's what we're going to do. Let me switch back over here. We're going to do task one. So if you are digital, then I'm sorry, you guys are on your own. But good news is I made a video of myself measuring out the holes with a caliper, so you guys should be able to get the distances or the diameters of those holes using the caliper measurements in that video that's provided. So here we go. Here's what we're going to do. We're going to measure the base plate drawing holes. So digital people, look at the video. In class, we're actually going to have these and we're going to measure them with calipers. And so it says to measure all of the holes, top and bottom, assigned to your pair. Use hole notes to record the hole sizes on the base plate drawing. You don't have to have the base plate drawing printed out. You could just write the hole notes out on a piece of paper. Okay, and it says when finished, give the base plate and the drawing to the other pair so they can measure. Once again, if you are by yourself, if you're not actually doing this, then you're going to, sorry, if you're doing this by yourself, then you don't need a partner. So that's what I'm trying to say. So you're going to measure these holes, 1, 2, 3, 4, 5, 6, 7, 8, 9. And whenever you measure it from the top side and the bottom side, what we're going to do from there is you're going to measure, well, actually, I guess in the video I just did the top side. So don't worry about the bottom side. I just measured the tops, and I think that'll be okay. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 holes to draw them out. And what you're going to do is you're going to either on a piece of notebook paper sketch out this shape of the base plate, or you can uh, have this drawing printed out, and all of these are the size, the relative dimensions for if you were actually wanting to cut the plate. So what we would need to do now is there are 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 holes here. So you're going to, here's what I would do. I would number these holes. I would say like, this one's number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8, and number 9. And I would just write out, 1, 2, 3, 4, 5, 6, 7, 8, 9, and I would make hole notes for every single one of these. Do they have a counter bore? Are they simple holes? Are they through holes? Whenever you saw them in the video, were you able to see straight through them? How deep are they? I'll go ahead and tell you that the depth of the object is a ½ inch. So the hole depth is going to be a ½ inch through. So in your hole notes, you're going to need to make sure that they say a ½ inch through. Okay, so this is what we're going to be needing to do for part 2 is we're going to need to have our hole notes for every single one of these holes that we have measured and the dimensions to them. The dimensions need to be measured to the nearest thou. Okay, the dimensions need to be measured to the nearest thou. So, like as an example, I'll go ahead and I'll give you an example that we can use. Let me see if I can pull the video up of me doing this real quick. I think this is it, and you shouldn't get blasted.
Okay, this is the Trammel Toy base, and as you can see, there are several different holes inside of it. From the look of it, they kind of all look the same. However, we're probably going to find out that with our handy-dandy calipers, that these. So I'm going to measure these out for you, and like so. Pull it down a little bit so you guys can see.
I'm going to pause the video so that we can actually see this. All right, so this measurement is accurate to the nearest thousandth of an inch. So that's going to be 0, 1. These are in tenths of an inch. So the first two decimals are going to be here. This is 0.1. I haven't made it to 2 yet, so that's 0.1. And then the next two digits are going to be 70. There's a little bit of parallax there. Parallax is what happens when your instrument isn't like straight on. But I know that mine's tilted a little bit, so I'm going to call this 70. You can call it 71, and it's not going to make that big of a deal. It's like literally 1 thou, so it's not gonna change anything. So this is going to be 0.170 inches. So that gives me my dial measurement using a caliper to the nearest thou. Okay, so the first two digits come from the slide. The next two digits come from here. Okay, and you can pretty much see that these are all through holes. You can see straight through them on them. And they're simple. There's no counterbore. There's no countersink. So when you're making your hole notes, do keep that in mind. Okay. And is there anything else that we have to do? Let's go back to our um, activity here, and let's see if we've got anything else that we need to do for part 2. We are going to, let's see, measure all holes. When finished, give the base plate down. So we're not making a 3D model of the base plate. That's good, because this would take a little while to get all the holes ready to go. So this is what we're going to do for part 2. This is your turn in. You're going to turn in the hole notes for these holes, and the video is provided. And then on part 3, we will start actually modeling one of the blocks, one of the slide blocks. So like these are going to be the slide blocks. We'll cover that the next time for part 3. All right. Have fun, and I will talk to you guys next time.